Okay, I think I'm here. So that was all very weird because Companion has refused to connect to OBS, which means none of my startup scripts or anything are working. None of my scene selection is working. Additional. Additional button press required? Does that mean there's no audio? It looks like there's audio coming up in OBS. Yeah, I'm flying blind. Okay. That was... This thing not working was the last thing I needed today. I... Oh, no, the audio is the additional button press. Yes, thanks, Michael. Yeah, to raise, thank you. Audio is good. All right, now that means that I have to fuss around for just a moment and click into there. Okay, clicking into cast note. Get started. Go to login. Username and password. Go, go, go. I'm getting there. I'm getting there. All right, maybe while that is logging in, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Okay, I'm getting there. I'm getting there. So active streams 1. Okay, now I've got to click get started again. Now it shows me those, and I'm in. Okay, I'm in. So not having scene control is going to cause me some problems with what I was wanting to do today. How are we going to... Okay, we'll work around it. We can make do. So good morning to Michael Wires, Crispian, Amanda, Dave Paul Jones. I saw a comment from Dave earlier saying, still working on Testomatic, must be a big project. Yeah, I've barely scratched the surface. I'm just getting started. This is literally going to be a multi-year thing for me. And if I continue with it, I don't think it's ever actually going to end. It's going to be one of those underlying foundational things that just keeps having more and more done to it. Good morning to Simon, Jax Tech, Grant Mazels, Tabraze, Sharky, and Imi, Tech Nebulous, Andrew B, Johnny Begdale, Russell Rennie, Mark Laguda, Andrew B, Wagon Loads, John Whips. Is there anyone else in the in the chat? It'll update its list in a little bit. Okay, so all right, I'm going to launch Fusion because I want to show you some things. Yes, as Michael says, projects never end, they just enter the maintenance phase. Oh, and did I say hello to Gavin? I just saw Gav in the chat. Oh, for the Testomatic itself. Yes, I've been thinking about that actually. Tinker. So, Tinker said, project won't be complete until John creates carrier boards and test procedures for all the parts of the Testomatic itself. I was thinking about this when I did a revision of the main Testomatic PCB a little while ago. You know, when I was doing the last revision, and I was thinking, this is a test PCB. It has 0 test points on it. Okay. So it would need, yeah. It wouldn't actually be practical to put test points on the main Testomatic PCB for all of the signals. The only way it's going to be possible to test it is to have something like a setup where there is a test module, like a test module that plugs into it that cross-links some of the I/O, and maybe have like a self-test type procedure that it can run through. Maybe test points for the fundamentals. So test points for things like the power rails that it generates, that it sends off to the devices that are connected. And then for the actual I/O pins, it needs to, yeah, okay. There is a whole lot to consider there. Oh, Okay, I was just going to say, someone needs to test TTS. Let's see if this works. Let's see. TTS is catching up. Hopefully we'll get Tinker's comment in just a second. Tinker's evil laugh.
Wahahahahaha.
Yeah, it worked. Yeah, Simon said plug the Testomatic into a Testomatic. Yes, I have very seriously been thinking about how do I test the Testomatic, because it comes down to it's a little bit like reference measurements. If you are making how do you trust the results of something if you haven't tested the thing itself that's taking the measurements? It's like when they were thought went from my brain. It just evaporated. I had it there. I had it there. Okay, where are we? I'm in Fusion right now on a screen that you can't see. Henrik is testing it. Let's see. Come on. Everybody get ready to dance. Or dance. Whichever. Dance or dance. As you prefer. Thanks, Henrik. So that is a €1.49 burger, it looks like. Henrik sent me a virtual burger. What am I looking for? Oh, okay, I know what I'm looking for. Color sensor. I moved everything into a subdirectory. So, I'm going to show you some of the things I've been messing around with since last week. Now, last week we experimented with the Happy Burger, says Henrik, yeah. Andy, welcome Andy, late to the game. My personal startup scripts completely failed during the holiday breaks, yeah. So, added to the chat, there is Gavin, Andy, Henrik and Tinker. Never finished, only abandoned. Yeah, abandoned or enter into maintenance mode. Now let's see if this is going to work. I've got to remember how to drive all this stuff manually now that my magic buttons don't work. Okay, I'm going to go to that and hopefully, oh yeah, I think you can still hear me at least. And that. Which doesn't really work very well as a picture-in-picture, but oh well. With no scripts, that's the best we've got. Okay, so I saw that there were some other comments there. Back there. Wagon Load says, would a PGA work as a test point bridge? Programmable test point switchboard. Maybe? Oh, yes, I saw Wagon Loads ask the same thing earlier and I missed it. PGA, so Programmable Gate Array, I think that stands for. Is that correct? Let's see. PGA, I'm going to check. Programmable Gate Array. Oh, field program, FPGA is field programmable gate array, yeah, but what about just PGA? Is a PGA different to an FPGA? Maybe it's just the same thing. Yeah, okay. Google's PGA, John gets golfing sites. Yes, I know. That's why I specifically... Oh, programmable gain amplifier, says Tabraze. There are so many things it could be. That is what I'm talking about, said Wagon Loads. Yes. Tinker says FPGA is field programmable. Yeah, but are there any that aren't? Maybe the original PGAs were not field programmable. They had to be done at the factory, maybe using a mask or something. And it was only later that they became programmable after fabrication, or after, not fabrication, Anyway, what am I doing? Okay, so last week we looked at this thing, which is the shroud that goes over a 5mm LED with a color sensor down inside it. And I have it, let's see if I can switch this. I think this thing. Okay, so you can see it here. This is the 3D printed shroud. I've screwed it through the pressure plate. It's got the I2C cable coming off it. And I left the holes are very slightly oversized. They're like 2.5mm holes for a 2mm screw. And I haven't entirely tightened it down, which means there is a little bit of play in it, so that as it goes down over the LED, it'll self-align and guide itself into the correct position. So you won't be able to really see it because it's all just dark, but up inside there is the light sensor, which gives us the red, green, blue, C and UV, I think it was, channels as I2C data. Oh, okay, so Tinker says, original PGAs were like original proms, took fancy gear and voltages. Oh, okay, yeah, so you'd need to do like use a high voltage programmer or something to set them. Paul, good morning, Adelaide. Yes, okay, so Wagonlight says, use PGA to make a software-defined switchboard for test points to choose which test points to route. Okay, this sounds like a far bigger rabbit than I want to chase in my current hazy state of mind. So I'm going to stick to the simple stuff, the things that my puny brain can comprehend. So this is the test shroud for a 5mm LED, and this seems to work fine. So this is what we were using last week, and we were getting data out of the sensor. And since then, hang on, I need to mute for a second. Bad. Overnight, my chest infection thing seems to have come back, so I've been feeling really rotten today. So I then did this, which was a bit of a failure. Well, it would probably work. So this was my idea of making a shroud that would go over an 0603 LED. And I printed some. I have right here. I've printed a couple. The problem is that what I was trying to do was make the geometry big enough that this circle will encapsulate an 0603 LED in any orientation. So if we have a look at the diameter of that circle, it is 2.8mm, and then just in order to be able to print, this can't be super thin. The end point here has to be wide enough that the nozzle of the printer can do a perimeter or two around it. So I couldn't bring this in much closer. This is basically at the lower limits of dimensions of 3D printing with any degree of like a clean result. Beyond this, it just becomes a bit of a mess. At least with normal FDM printing. With something like UV cured, you know, the UV cured printing, resin printing, you could get finer features than this, but this is getting down towards the limits. So I did this, I printed a couple of them, and then I did some test fits onto a PCB. So I have a PCB here, and I'll show you what I'm thinking about how to do this, because my normal process of just hitting a button and getting the correct camera do not work. So how am I going to show this? Right here is an LED. You can probably just see it between my fingers, right there. And next to it is the current, which side? Next to it is the current limiting resistor, which is associated with the LED. Now, this is a not a very dense board. There's plenty of space, but the current limiting resistor and the LED are right next to each other. What is the spacing on those? Not particularly large, not tight. Looks like it is on 2.5 millimeter spacing, approximately. Yeah, 2.5 millimeters. So the LED and the resistor are side by side, parallel, 2.5 millimeters apart. And that's pretty normal on a board layout. So it's quite normal to have a couple of parts that are, if you have an LED, it's not going to be sitting in total isolation miles away from anything else with plenty of space around it. There will typically be other parts near it. And that means that if I'm going to put something like a light sensor with a shroud that descends over the LED and blocks it off, then it needs to be able to clear adjacent parts. And this doesn't. It kinda does.
At Austins_creations said, embedding you either need a resin printed part or TPU to help squish, seal.
Yeah, potentially, Austin. Yes. Oh, and also, hello, Austin. A couple more people have joined the chat. So Austin is here. Paul Gray, I said hello to earlier. Evil Deece is here. SK Photo Guy. Evil Deece. Evil Deece, are you going to be at Everything Open in a few weeks? Because it would be very cool if you were. So, where are we? Okay, so this was the progression. I did a test print of this part, and it does actually work. Like, it fits over an 0603 LED, and it brings the sensor down. Now with this one, if we do I have a section analysis on it? No, inspect. Let's see, section analysis. Just go from there, that'll do. Actually, no, I'm going to do it, cancel, I'm going to do it from the other way around. Inspect, no. I want a section analysis on that axis. Okay. So, what you can see with this one is the cable comes down from the back, and then the color sensor sits in the bottom of this cavity. The top of this is where the LED comes through. So a 5mm LED goes into this hole. It has a curved top, and the top of the curve ends up approximately where my cursor is. So it fits into that space neatly. The sensor goes just here. So the sensor, and that's why I have this gluing guide. I'll show you this as well. So this gluing guide has a spigot sticking up on the inside. So I printed one of these, and what I do is I put this shroud gets inserted into the gluing guide. That spigot goes up inside it, and it goes to where the LED would be. So it blocks off the hole for the LED. And then I can put the sensor down in here, and I know that when it hits that, that stop point, it has reached the end of this. And then I can put a bit of glue on the wire, and the sensor ends up in the correct location right there, because there's nothing else to stop it. If otherwise the sensor can just keep going straight down and end up in this area somewhere. Or I might not put it down far enough, and it might end up here somewhere, which would probably still work, but I just wanted a really consistent way of making sure that when I put the sensor into the housing, it ends up in the exact same place every time. So that's why the gluing guide provides this face. So that face right there is what goes up inside here and acts as an end stop for putting in the sensor. Wagon Load says, looks like you're trying to solve my I2C optical dock problem, optical tube shroud. Very similar, yes. And ultimately I do want to do this with optic fiber instead of putting the sensor directly in here. But that is for a future iteration. I'm doing this in multiple stages. The first stage is to take the sensor and put it directly over the LED. but that means having a cable running down to it, and it means a shroud around it, all sorts of things. So ultimately what I want to do is make a little test module which will have a number of these sensors in it, probably 8, and then have optic fiber that goes to a shroud that goes onto the location of the target LED. The other end of the fiber goes up to the sensor, which will be in the centralized location. Wagon Load said, would a fiber optic cable help direct the light from the LED? Yeah, exactly. That is the plan for the future, but that adds a whole lot of uncertainty and complication. So I am dealing with the simple case first, make this work, and then I'm going to start complicating the mechanical optical side of things. So, so this version seems to work really nicely with a 5mm LED. So a round 5mm LED into this works just fine. And yeah, and we had the software working for that last week, which is great. So, and this one, you can see that because this whole thing is significantly smaller, because it's going over an 0603 surface mount LED, it's not going over a big 5mm through-hole LED. So this end is much smaller. The sensor, if I, how am I going to do, which direction should I do an inspection? Let's go that axis. Yeah, you can see that there is a flat point at the end here because the sensor is bigger than the 0603 LED. So it sits in the bottom. So what I'll do is put the sensor down with the wire attached to it until it hits the end here. It'll just sit against this little lip. The sensitive part of the sensor is in the middle of it. So it will then be exposed to this hole and then it can be glued in place. So that's the theory for this one. Yes, but it just ends up being too bulky. Hang on. Sorry, had to cough and take a drink again. So, this was a little bit of a failure. It would work if the LED was quite isolated and it wasn't near anything. But that's not reality. So I did 2 more. I did a lateral and a straight, and you'll see why. Whew, not good. And you'll see why. So, instead of trying to make a round aperture that will fit over the LED in any orientation, what I did was specialize the orientation. So I have this one where the LED is aligned with the mounting holes. And you can see that it just goes that way. And then I've got this other one where the LED is perpendicular to the mounting holes. They're basically the same thing, but this aperture is small enough that it just fits nicely over an 0603 LED with a little bit of a gap. There is a slight chamfer on the inside edge so that as it's going onto the LED, it'll tend to self-align. It won't just sit on the top, or like it won't, if it catches the edge of the LED, it shouldn't just sit on it. It should sort of skate off the edge and self-align to some extent. That's the theory anyway. And you can also see, this is a little bit of a silly thing, but yeah, I think it'll be helpful.
At Tinker001 says, but WHT will you do for an array of 0603 LEDs?
Oh yeah, that's going to be an issue. I haven't got to the ability to solve that yet. That's probably going to require, at this stage, it would probably require a custom shroud. So some kind of a shroud that has 8 sensors in it, or however many are required, and sits them all in the correct location. So it would be an array of sensors with an array of apertures custom made for that particular target device. But ultimately, I want to be able to do that with optic fiber. But for now, I'm not jumping straight to the end goal of the most complicated situation. I'm trying to solve the simple case, and then once I've solved the simple case, I can then start to expand and generalize it a little. Yes, and as Tinker says,
001 said, except that the sensors are much bigger than 0603.
yeah, they are, and that is the point. If I have an array of LEDs that are side by side close together, that is the point where I will need to use optic fiber. But I'm not there yet. I've got to make the basics work first. So the thing with this is that because the body of the shroud is rectangular and it fits tight, you know, not super tightly, but it fits directly around the LED. If there is a resistor and an LED in parallel, directly side by side, the thickness of this side shroud is small enough. In fact, I don't even remember what it is. What is it? From that face to that face is 0.5 of a millimeter. Yeah, okay, so yeah, you can see the scale this is. It's pretty small. To be 3D printing this, it's down at the lower limits of FDM printing. So 0.5 of a millimeter thick on those walls, which means that fillet is something like 1/4 of a millimeter across. And that is narrow enough that it will fit in between the LED and the adjacent resistor. So this will solve the problem when I have a, in fact, I'm going to come back to here, test modules, and test module, TMod, is it this one? There is one I was messing around with, module plates, yeah, it must be
Build
this.
them out of HDPE.
HDPE? Make the LED shroud as a separate rotating end piece so you can rotate it to any angle. Yes. Oh, Jordan is here. Hello, Jordan. Out of HDPE. Mill them. Yeah, that's true. I could mill them. So this is the pressure plate for, well, you're not really going to be able to see it properly, but for this board. It's the one that I've been using, this board actually, one of these. This is the one that I have been using as my test case. So if I want to make it work for this board, and that gets me to the starting line of having one board where I am testing an RGB LED and a regular LED. So there are exactly 2 LEDs on this board, and if I can cover the big 5mm RGB LED and the surface mount 0603 single color LED, that covers the, like, that's LED sensing 101. It gets us to the base point and then I can start expanding from there. So what you can see on this pressure plate, in fact I'm going to turn on, where are we, bodies, turn on a couple more pieces for it. So this white piece that you can see, this is the orientation of the test module. You can see the top plate, the middle plate and the base plate under there. I'll turn off the base plate and the top plate just to make it more visible. So the pressure plate, that's interesting. Oh no, that's fine, that's fine. Sorry, I just saw the tab on the support plate coming in, intersecting where the sensor is going, and I had a momentary heart attack. But no, that works fine because that sensor is under the PCB and it doesn't obstruct anything. So that's cool, I think. Oh, actually no, I should do something about that because that point, yeah, anyway, there are pins from the through-hole LED coming through at that point. I need to relocate that little indentation notch so that it's no longer directly underneath. Now, a couple of things. One is that... questions. Evil D said... the rainbow buff LED array for Vorons have a pile of 00603 addressable RGB LEDs in a small space. Let's see what is going on with that. Oh, cool. Rainbow buff. It's an eye-catching revival of the Voron Stealth Burner printhead logo with rainbow backlighting. So, yes, testing that would be interesting. Stretch goals. Yeah, I know I'm repeating myself, but as I keep saying, I need to solve the simple case first. Then I can start solving the more complicated cases. So, my goal is solve the case for this board with a 5mm through-hole RGB LED and an 0603 surface mount LED. And that's it, nothing else. Now there was a question. Oh, get out of the way. Sorry, there was a pop-up in in the YouTube management interface. John says, did we decide that a CCD sensor and image recognition was too difficult? Not too difficult, just a different way of doing it. And one that does have other complications. Yeah, we've talked about that a couple of times. One of the issues is the camera would need to go on the bottom of the pressure plate, which is 30mm from the face of the PCB. So the camera would be, the back of the camera would be 30mm away from the PCB, which means effectively your focal distance is going to have to be something like between 10 and 15mm. So the actual camera is only going to see a very small part of the board. And sorry, my brain misfired because I was also half reading things in the chat. And now I don't know what I was talking about. Oh, I need to go back to bed. What am I doing? I seriously have no idea what I was just talking about. No, it's gone, totally gone. So, yeah. Okay, so I was starting to talk about the reason for doing lateral versus...
At Tinker001 said, you were pointing out that cameras don't see through the plate very well.
Ah, yes, that's right. The thing is that there is a lot of stuff in... The camera can't be above the pressure plate because there is just way too much stuff in the way. There is the big mounting bracket in the middle. There are the pressure pins that go down. There's... Yeah, and thank you, Tinker. Yes. So I can't mount a camera up high so that it has a view of the entire PCB. The camera would have to go under the pressure plate, and there is still the alignment issue. So if you say you have LEDs turned on, the LEDs will give you a bright spot, and then and also there are ambient lighting issues. what I would need to do is enclose the tester so that it is all blacked out, and or otherwise I'm going to have things like reflections off the board. If there are varying lighting conditions in the room the tester is running in, you might get different results. Like you might get different levels of illumination, because I don't necessarily just want to tell if an LED is on, I want to tell how bright it is. So I need an actual number coming back that can be used to look at thresholds and say, is it within an acceptable brightness range? The other thing is, so if it's slightly misaligned, you can't work on the basis of just looking at a pixel location. You'd need to do things like use OpenCV to generate a bounding box around the bright part, and then check within that bounding box, like maybe in the center of the bounding box, what the RGB values are. And so you'd need an OpenCV pipeline, and all of this is just way more complication than simply sticking a sensor on it that I can query over I2C and it just gives me numbers. Like, the complication with this, using one of these sensors, is so much simpler than trying to deal with a camera. And also, cameras are... for anyone who has tried to film RGB LEDs, for example, if you've gone to Christmas lights and there are, all these intense colors and things being shown in some kind of an animation or a pattern, and you grab your camera and you think this looks fantastic, and you film it, later when you look at it, it's always disappointing because cameras just do not respond properly to that sort of lighting. Paul! Good morning, Paul. Often if you try to film something, like an RGB array that is doing something, it'll all just look kind of washed out and whitish, because the camera and the software that deals with the signals coming from the camera can't really differentiate the RGB properly. So if you're doing something like trying to analyze the performance of an RGB LED, doing it with a camera, I think it's adding an expensive device which will be really mechanically finicky to set up, and then layering a whole lot of software on top of it, the whole OpenCV chain, compared to just, like, last week we saw that we could, in, how much code was it? It was like 20 or 30 lines of code, and we were getting the RGB, C and UV values coming back out of the sensor over I2C. It was really easy. Yeah. Evil D says, if color sensing was supposed to be easy, nature would have evolved color sensing sensors already, maybe even with built-in lenses. Yeah, and with maybe with self-adjusting irises as well, so that you could compensate for different levels of light. John says, camera equals too complex for little or no gain. Yeah, so it was actually my original plan to get a camera, stick it on the frame of the tester, pointing at the board, capture it, and then just process it in software. And these days, a lot of the time, if you're wanting to sense something, the low effort approach is to get a camera and just point it at the thing that you're wanting to sense, rather than using a more specialized sensor. But in this particular case, a camera is just a whole lot of extra expense. Probably, I don't know how big OpenCV is, but could conceivably be like 1 million lines of code in OpenCV. I don't know. It's rather than 20 or 30 lines of reading some I2C registers off a sensor that costs like $2. So anyway, Crispian said, it did, mammals. Yes, I think that was the point. Andy said, well, yes, and at some point soon you'll also want to perceive PCB assembly test information
And
that can
Amanda
only...
underscore RFT said, don't forget the nerd brag or achievement of the week.
Aha!
Mine is, I got the first version of the redesign of the 3D printed glass case done this week.
Ooh, nice. Okay, I will get back to Andy's comment in just a second. Yes, Amanda, nice on the nerd brag. So if anybody else has a nerd brag they want to throw in, then go for it. So got the first version of the redesign of the 3D printed glass case. What was the glass case? Is this some? Have I totally forgotten something that you've talked about previously? What project is the glass case? So Andy made a very important point. Okay, I should preface this by saying I am not against taking photos of the boards or using cameras as part of the solution. And it is in fact my plan to do that. It's just not for this because it is, yeah, okay. So the important point that Andy made is at some point soon you'll also want to perceive PCB assembly test information that can only be captured via a camera. Yes, definitely. That is very important for things like detecting tombstone parts. So this is AOI, Automated Optical Inspection, and I definitely want to include AOI. So AOI machines are incredibly expensive. So starting point probably like $100,000. And I've been thinking about different ways to incorporate AOI. And in fact, the third, so as many of you know, I have 3 KO pick and place machines. The third machine, which was never actually run, like I bought it secondhand, but the previous owner had bought it in order to, so he bought the first 2 machines and he was using those for doing board assembly. The third machine, he specifically bought to build an automated optical inspection machine. That was the whole point. So his area of expertise is vision processing. He does lots of OpenCV stuff and custom vision processing algorithms. So that is his thing, and or one of his, several of his things. So the idea with that was that the PCB would come out of the could come out of a reflow oven or whatever, and it would go into that third pick and place machine, which would no longer be a pick and place machine. It would be using the mechanical structure to be able to move the camera over the PCB, take pictures of different parts of the PCB, which could be stitched together or they could be processed independently, and then use a vision pipeline to detect tombstones or parts missing and all of those sorts of things. So that was the project that he had set himself, and then he ended up selling me the machine because I was there buying the first 2 machines, and he ended up saying, well, might as well sell you the third machine as well. Oh, Evil D says, KO seems overkill for that when a huge diode laser gantry can be had for less than $200. Yeah, but they don't have... yeah, Stephen. Okay, I've got to change the view. They don't have a conveyor belt through them and other things. So yeah, by the time you do things like build the conveyor belt mechanism, and everything else, it becomes a lot more of a project than just an XY gantry. So where am I? The reason that I did which one is this? Lateral and straight. And you can see that on the back of them, I put a little ridge in it, so that if you're looking at it from behind, you can see the alignment of the LED. On this one, it goes straight. On this one, it goes lateral. I was actually thinking about doing a multicolor print and making this yellow or something. And that is so that if I've got a pile of them, I can just glance at it and say...
Tinker001 said, don't know anyone with a mostly built board conveyor design.
No, don't know anyone like that at all. Yes, and also the other thing is that I already take photos of all of the boards. But that is done in a light box, not in the test jig. The problem with trying to get photos in the test jig is there's just too much stuff. Once the PCB is loaded in this test jig, you can't see anything from below it, so you can't get a bottom photo, which I need. And looking at it from the top, you've got the pressure plate with all the pins, you've got the mechanism in the middle, there is all sorts of stuff there. You cannot get a photo of the top of the board either while it's in the test jig. So while it's in the test jig is not the stage in the process where it is optimal to do optical inspection. That needs to be done at a different stage of the process. So at the moment I have, in fact, let me see what I can find here. I have thousands of photos of PCBs. But that needs to be done in a light box with the board supported in the middle of the light box so that there is a bottom camera and a top camera, and you can photograph both sides.
Said, next squirrel, photo station on the output of the reflow oven.
Ah, yeah, so Tinker says, next squirrel, photo station on the output of the reflow oven. Yeah.
At Amanda_RFT said, can you just put a pipe box over the conveyor with two cameras?
The problem is the conveyor itself blocks the view as well. So, where are we? Processed images. I'm just gonna, what have I got in this? This folder has 1009 images in it. I'm just trying to find one that I can open that is not going to be a problem. Like one of my own boards. There are lots of customer boards in this folder. Where is one? Oh, that would do, I think. No, that's not a very good example at all. What is this board? Nope, can't show you that. That's a secret client that I'm not even allowed to mention. Oh, come on, there's got to be something back here in my history. What about that one? Nope. Okay, what I might show you is just a picture of a board that is not yeah. Oh, hang on, this might do. Okay, this is an old one, but anyway, so here I've got a folder of processed images, and you can see this one, for example. So this is from 24th of January.
Don't show the missile control boards.
Yeah, I won't show the missile control boards. So this is 2025 images. So this is 24th of January 2025, serial number 1730. And this is, hang on, I've got to bring it back up on here. So this is a photo of a Rack 32, obviously. You can see the serial number there, it's got the QR code. you can try going to it, but you won't get past authentication. If you try going to that URL, you might actually, I think you'll get an SSL error right now. That goes to a URL which is a redirect to the real portal. So I have, but this photo was taken in a light box. The board is just put in there. It's got LED strips inside. There is a lid on it with a hole. And what I do is, at the moment, I sit my phone on it, on the top of the box, and the hole is oriented so that the phone's camera is directly over the hole. And take the photo, and it then gets synced by Dropbox. Then it gets run through an automated processing thing that crops the image in. So it finds a bounding box of the object in the image, and it adds a certain number of pixels all around it. I can't remember how many it is, 20 pixels or whatever. So it adds a slight boundary. It crops the image. It finds the QR code or barcode. It can work with either, and then extracts the serial number, and then it renames the image with the serial number prepended. So you can see that this one up the top is serial number 1730, and it was the date 2025-01-24, and it was at 5:20 p.m. and 8 seconds was when this photo was taken. So that can then be stored against the record for that specific board. So if I go into the portal and look up that board, the idea is to be able to see photos of the board. And for these photos...
001 said, one of your PO bypass jumpers is misplaced.
Oh, they're both off. So if I scroll right in here, you'll see that this one is slightly twisted, and it's only over one pin, and this one is also only over one pin. They're offset and hanging off the edge. That's deliberate, so that the bypass is disabled by default. And if you want to enable the PoE bypass, you take the jumpers off and move them and stick them in their correct place. I should probably do something like put these in a little Ziploc bag inside the bag for the product, instead of having them hanging off the pins like that. But yeah, I should figure out a better way to do that. Aha, the weekly stupid Java update that fails every single time. The only thing I can do is remind me later, because skip this version and install update both cause explosions. So it is deferred until 11 o'clock next Sunday, so it'll come up in the middle of the next live stream. So anyway, my point was, I have photos, a couple of photos of boards. Oh, hang on, what was back there? Oh yeah, these are some, these are interfaces for the UT61E, the multimeter interface. Many, many boards. So I have photos of almost all boards that have been made in the last Tom and I have assembled in the last 2 years or so. But it's not practical to take photos of a board while it's in the test jig. It has to be done before or after. And I think it was Amanda pointed out, after the reflow oven. Yeah, so what would be nice would be, there needs to be 2 stages of taking photos. It is, Henrik is asking, who messages you? Is it something important? It's Amanda sending me pictures, and I haven't actually stopped to look at what they are.
Who messages you? Is it something important?
Oh, I just opened Facebook to check the messages, and hang on, I'm gonna bring this up on screen because this will tickle a few people. Look at this. Yeah. TE number 15. I have that one. Someone's been looking for Talking Electronics issue 15. Finally got number 15 mag. Found this one in New Zealand a week after I found one in AU. Goes with my original folder of 1 to 14. Yeah. Now, I'm just going to check what it was. Oh, okay. Login. Yeah, okay. So Amanda just sent me a screenshot of what she gets when she goes to that QR code. Yes, that's right. So if you actually had privileges to log in, you would see info about that board. What was it? 1730. Portal, device 1730. Am I authenticated? I am not. So, yeah, if anybody did actually go to that, yeah, there needs to be some work on this, but yeah, if you did have privileges and you could authenticate, and you went to that URL, see, I'm giving away the URL here, but it doesn't matter because you can't get in. You would see who the board was made for, what the device type is. So in this case, it's an ESP32 rack controller with the PCB antenna, not the external antenna. It's got the SKU on it, serial, hardware version, software version that was installed. 5th of March 2024 is when it was created. And so that is... Mitch and I need to talk about the terminology for this. We've talked about it in the past, but we need to kind of clarify it, because making a board can be spread over a period of time. There is no one date. There is no one date on which it is made, because you might put on paste, pick and place and reflow it on one day, and then it might sit in a rack for a week, and then it goes onto someone's bench to have all the through-hole parts soldered on, and then it goes back in a rack, and then it might sit there for a little bit longer, and then it goes to have firmware flashed onto it and tested, and that and then even after that stage, it might be 100% ready to go, fully flashed, tested, etc., but not packaged yet. So then it might be sitting in a rack marked as passed, and it hasn't been packed, like put into its anti-static bag, etc. So that might happen sometime afterwards. Now, often it will all happen in one day. A board will go from nothing to fully packed in one day. So the date is the date that the board was assembled. And it's but what we really need is to be tracking.
At Tinker001 said, I have boards from 2019 with only half their parts installed.
Yeah. Are they still relevant at this point? So this is really, we were half joking about it being incept date. It's when the when the replicant was incepted. So there is a starting date. It's really the record creation date. So the record for this board began at the point when assembly began. So it's whatever day we began putting that board together. So that'll be the day that it got its paste and pick and place and reflow, which all happen as obviously as very rapid consecutive steps, because you can't leave the paste on the board. So that is the date on which assembly of this board began. But then, well, in this particular case, you can see it was 5th of March 2024.
At Tinker001 said, I actually pulled one out, finished it for a small project last week.
Oh, cool. Well, it's good that you had some half finished then, so you were most of the way there. And you can see it was tested on the 11th of March 2024. And in this case, it's just, this was pulled from a spreadsheet So it has a note to that effect. Anyway, I'm not going to go into this in too much detail right now. Oh, when was that? 29th of October. Ah, yeah. So this is, yeah, these boards, that's right. So these particular boards had, these were a bit like Tinker's boards. They were sitting for ages on the shelf in a rack, and I hadn't got around to testing them or flashing them or whatever. So there was a firmware update. Firmware 440 was installed on them, October 2025, which is quite recent. Messages. Hang on, I've got to do it again. Okay, audio is back with the silky smooth tones. Ooh. Where are we? Oh, Andy says assembly line path also includes failure loop back to earlier task. Yes, exactly. I wonder if. All right, I'm going to see if I've got something. I started doing a diagram for this. Oh, where is it? Why isn't it there? I'm sure that I began that. No. I wonder. Okay, I'm going to check Keynote history. Where is it? So Keynote recent documents. Not that. Oh, hang on. Maybe this? No. Oh, somewhere I did a flowchart of the process. I'm gonna have to find it. It's I thought that I would have put it in my. Oh, hang on. Maybe it is. It is quite possible that it is a local document on my laptop in a flowchart program. Yeah, I'm going to find this some other time. Yes, it is not linear. It is very definitely not linear. There are branches. It's a pipeline with branches and joins and and loops and all sorts of things. The actual process of taking a board from beginning to ready to deliver is not a 1, 2, 3, 4 type exercise. So yeah, if a board fails testing, it can loop back around and go back to rework, and then after rework it has to go through testing again. So it might go through multiple cycles of testing and rework to yeah, anyway. There are also optional subroutines, like some boards don't have firmware, some boards do. So yes, and I do have it flowcharted somewhere. Wagonlight says, can your PNP place QR stickers on each PCB so each one gets a different number? That would be really nice. It would be yeah, it'd be nice if it could be done in the machine. I have thought about that a number of times in a few different ways. For example, laser etching the QR code. Austin says, even better, Wagon Lows JLC now offer that as a service. Yes, but you can't have a custom prefix on JLC's QR code service, which ruins it for me. Let me see, JLC PCB QR code. They can do a QR code on bottom silk screen. No, check, yeah, hang on. I'm just trying to find it on JLC. I'm searching for it and all the results are things like EEV blog forum discussions of it. I want the actual thing. I want the thing on JLC. JLC free customization service. Add a free... Okay, well that's a Facebook post, which is no longer available. Come on, JLC. Just show me... That's another JLC Facebook post, which is no longer available. JLC PCB QR code. Let's just go to JLC and search from there since Google is totally failing. It's just giving me AI garbage instead of actual results. So, closed on January 1st. That's fine. Capabilities now.
We are looking still to 3D print.
Where was it? Tinker says, new project, tiny laser engraver in the PNP line. Yeah. Yes. So that is how it is done in high-end factories. They have laser etching in the production line so that a PCB comes through and it can be laser etched. So what they do is they have an area set aside for something like a QR code or whatever marking they want, and then it can be laser marked as it goes through the line. Now somewhere in here, capabilities. Okay, I want to find the QR code. Let's do a search. QR code, search JLC PCB. QR code. Common design issue experience, how to mark on a PCB. Okay, here we go. Maybe this will help. How to mark on a PCB. So, no, I'm not going to use that method. 2D barcode serial number and serial code prefix. Serial number setting, unique number. I think it is quite possible that they have improved this since last time. So it now has a prefix. Enter serial code prefix. Yeah, I don't think the prefix was there before. So the problem was that the actual QR code that I want is not just a number. It is a
I've sent SMT
URL.
Discord. Is it the same thing?
I don't know. I will open Discord and have a look. No, I'm gonna... Oh, I was just about to try to kill that because it was going to open on the visible window. JLC PCB business card. Not quite the same thing. No, that's just like a PCB. So that was a... What I'm talking about is having a unique QR code printed on each PCB. So if we went for QR code, oh, it's got data matrix code. All right, I'm going to try. Let's see, that's help. Let's come to order now, and I'm just going to see what options I've got. PCB spec, where is it? Mark on PCB. Where is it? Confirm, confirm. Where is the option? Oh, is it only if you select like an advanced board outline, mark on PCB? Oh, here we go, yeah. 2D barcode, serial number. All right, so I wanted to go for a QR code. Maybe I can do it now. When they first released this, oh, you can't do slashes. Yeah, I think this was the limitation that I hit last time. So I can't do something like d dot. Oh, and I can't do dots either. I just wanted a text prefix, and you can't actually do it in JLC. So it's fine if you wanted, like say I wanted superhouse and then a number. See how that's coming out as superhouse underscore blah, a series incrementing number starting at value 1. And I could say, okay, I want mine to be at number 2345. It's going to start at that, and then it's going to increment up from that and make it a 10 by 10, and what is it, unique number and incrementing number. Unique number I don't want, so it could be something like this, superhouse 2345. And then the 2345 is going to increment, but this isn't enough. 2D barcode and number only, data matrix code, QR code, because I need a URL. The auto increment part needs to be an argument on a URL. Otherwise, this just doesn't work for me. So I can't use JLC's service to automatically put this on the PCB. I have to label them myself, which is why if I go to preview, and is preview open? Come on, macOS, what are you doing? Preview, I just tried to open you. Preview, open. There we go, okay. So recent was this. Yeah, so that is why I'm using this label printer. So these are chemical resistant, thermally stable, long life, abrasion resistant labels that I'm doing in a Brother industrial label printer. And the Brother software does auto serial numbers and does all of the tokenization stuff that I need. And that's why that QR, so down the bottom where it says 1730, that is the serial number. But this QR code does not just say 1730. If you decoded that QR code, it would actually be d.superlab.au/1730. So it's a URL with the serial number as the argument. Yeah, Austin says QR code needs login. Yes, exactly. And Grant says, can you put the special characters in the unique number field? Oh, that's an interesting, I hadn't even thought of that. Okay, so what if we come back to here and we go 2D barcode, unique number field? Oh, no, the unique number field is not something that you can change. So that is something that gets added by JLC, I think. I don't actually even know what it comes from. So you can specify the serial, the prefix, and then you can allow them to leave their unique number in the middle, or you can remove it. So if I had Superlab there, for example, I can leave their unique thing in the middle, but there's no box for me to be able to enter what the unique number is. I don't know what the actual point of that is, or why you would not remove it. Starting value, incrementing number, yeah. So it is very close. It would be really nice if when you had QR code selected. Now I would understand 2D barcode and number, does that allow anything different? Oh, I see, no, it's just whether it prints it underneath. If this system, if you select QR code, now I understand if you select barcode, why it does not allow you to do those extra characters, because typical barcodes, like a code 39 barcode or whatever, don't allow you to have a chunk of arbitrary text like a URL. But with a QR code you can. So what would be nice is if JLC allowed you with a QR code to put whatever you like in the prefix. At the moment they are artificially restricting this. They are preventing you from putting in, like if I type slash, nothing happens. I'm trying to type slash there. So I can't do a URL. I can only do basic characters in that area. But if I could enter the root of the URL there, ending in a slash, and then simply have the number follow on from it directly, that would be perfect. Then I wouldn't need to put stickers on the boards. It does introduce other problems in terms of keeping track of what you've done, because if, for example, I order a pack of 100 PCBs, I need to specify in the order what those serial numbers are, and I need to pre-allocate that range of serials and never use that range of serials for any other board. So I would then end up with so I would need to keep track in advance, and what I would need to do is pre-allocate and say, okay, I am ordering 100 PCBs starting from this serial number, and that block is now used. So next set of PCBs that I order of any type has to be after that block, like the next incrementing number. And it is very likely that in any particular batch of PCBs, there will be a bunch that aren't used, because typically you don't end up with exactly the number of PCBs that you need.
Can't you put that in the numbers field?
Henrik asked, can't I put the slash in the numbers field? No, you can't put anything in. It's just not allowing me to. So incrementing number starting value is that. So I can't type anything in there. I can put a number there, but I can't put anything but a digit. Like that's hitting stuff on the keyboard. They've just got restrictions on it so that you are limited to a prefix, which is characters only, no delimiters, and a number, which is just an integer. You can't use any other characters. Yeah, so yes, it would be cool if I could do that through JLC. It would save me putting stickers on the board, but it would actually introduce another issue. I would have to change my process for keeping track of serial numbers and pre-allocate blocks. And those blocks may never be used. Some of those boards might be disposed of, or, you know, life happens. So I don't care in particular about having holes in the serial numbers. At the moment, I don't have holes because boards are only assigned a serial once they are assembled. There is a stock of PCBs. PCB gets assembled, we end up with a board, it gets a serial assigned to it, and therefore the next one that's made after this is going to be number 1731, and then the next board is 1732, etc. And it doesn't matter what order you assemble boards. You might assemble product A, and then you assemble some of product B, and then you assemble some of product A again. The numbers are just consecutive, and there are no holes, no gaps. But yeah, I don't care about the gaps. That's not really the problem. Wagonlight says, can you use the substitute character that replaces the slash in URLs? No, it just won't let me enter anything like that. Tinker said, it was bad word blocked again. I don't know why.
Serialization at assembly simply makes more sense anyhow.
Yeah. What would be really nice would be either an automated sticker application machine or some kind of a laser-based process. So one of those. Anyway, this is far removed from testing, from reading from these things. Okay, so, okay, I have right here, not that you can see it, bad word it found was probably sense, maybe. Okay, so, as we discovered last week, these sensors have a single fixed I2C address, which means that if we want more than one of them, there is a problem. And the solution to that is this little board or something similar. So this board, in fact, I'm going to see if I can find it, PCA 9546. I will find this. Michael says, found in dictionary equals bad word. Yeah. It is this. I will bring this back up on screen in just a jiffy. Okay, so this thing. So this is an I2C multiplexer. And you may be familiar with these because we've been using these already in Testomatic. So right now there is an I2C multiplexer to select between the different I/O blocks. So each of the I/O modules on the Testomatic can have the same I2C address. They may not, they may be different, but it's possible they are the same. Therefore, there is an I2C multiplexer that allows selection of them. And so what this little module does is it's got the upstream I2C connection here on the end, and then it has 4 downstream I2C connections with quick compatible connectors on them, and a 4-way I2C multiplexer. And you can also see that it's got a couple of 10K resistor arrays here. So those are the pull-up resistors on SCL and SDA. There's a voltage regulator, I believe. What else is on there? Not much. It's really just a way of connecting multiple devices. So if you had multiple quick devices, or what is, I can never remember it, what is Adafruit's equivalent of quick? It'll come back to me.
At Tinker001 said, post the URL, John.
Post the URL. The URL for what? What about the first 4 digits is the board model and the remainder is the board serial number? Yeah, but the problem is I want a URL because I want my customers to be able to just point their phone at the board and click on it and pull up the history of the board. Grove connectors, says Amanda. I don't think they're quite the same as Grove. Grove are bigger. That's the Seed Studio equivalent. Tinker, post the URL. For the module you're discussing. Okay. Cool. I shall. In fact, I'm going to be super mercenary about this and get a get an affiliate link for it. So this is a 4-way I2C multiplexer board, and I'm going to chuck that in the chat because that way if anybody buys one I might get about 5 cents from it. So this is what I have in my hand right here. It's this board. And if we come back to, where's the pressure plate? This one. Now, what we have here is, just move some stuff out of the way because I've got things all over the bench in front of me. Now, these 2 areas here, this here and this here, are for mounting these shrouds. So one of these, actually not that one, in fact let's just close that one, don't need it anymore, it's irrelevant. Like one of these ones. So one of them will have an 0603 sensor, and the other one will have a 5mm sensor. So that one, 0603 sensor, this one, 5mm RGB sensor. So coming up through these slots, the reason that they've got the slot in the middle, that is so that the JST connector on the end of the sensor can fit up through there. So what I can do is poke the cable up with the connector on it, comes up through that slot, and then it gets screwed in place so that it sticks down underneath the pressure plate with the cable coming up above. So then we have two cables coming from two color sensors, and they need to be connected somewhere. And also you can see here these holes, so oops, that one and this one, this one and this one are for the pressure pins that go down onto the top of the PCB. These holes are for mounting the magnetic latch, which attaches the pressure plate to the gantry mechanism. And these two holes here, right there, are, now I've got to find it again, where is it? Are the holes that match, oh come on, that and that. So this little module can be screwed onto the top of the pressure plate. In fact, what I would do is put a little spacer in between, like maybe a 2mm spacer, and put some M2 bolts through. So there is going to be the module attached to the top of the pressure plate. These two sensors will plug into that module, and then there will be a flying lead that comes off the end of the module, which will be against this edge of the board, that will loop around and go to a quick connector socket on the test pin breakout. Sorry, the test pin carrier board. And that is why there is this. So this is for a vertical format, and this is for a horizontal format quick connector. And I've put them both on because I don't know which one I want to use. And if I go to, do I have it here? Is that the latest one? Is it? I don't know. Let's find out. Let's just open it and see what happens. Is it? Yes, okay, it is. So in the back right corner, you can see two footprints. This is for a vertical quick connector, and this one is for a horizontal quick connector. So those cables get exposed, actually, no, coming back here. Do I have an assembly? I don't think the assembly has the, oh, that's a version 1.1 assembly. I haven't done an assembly for version 1.2 of the breakout yet. Yeah, so that's where the connectors are exposed, either vertically through there or horizontally through there, with room to get your finger in to insert or remove a cable. So the cable will loop from that point over onto the I2C multiplexer, and then from there be wired out to the color sensors. And that way the Testomatic can use I2C to use the multiplexer to select which color sensor it wants to talk to and read values from it. I2C smoke detector on the pressure plate. Paul says, do you have a magic smoke sensor? Oh, nice. That's an interesting idea. A smoke detector. Well, in theory, the current sensor should catch smoke emissions. Oh, here it goes again. Oh, lungs not behaving. Yeah, so current sensors on the power rails that go to the device under test should allow detection of dead shorts and then killing the power very quickly to the device. Paul says you might not want to test that. Yep. Austin says, I think a thermal camera would be more effective than a current sensor. Yeah, so the whole thermal camera thing, back to that. Yes. Now, this is where things get really tricky, because I do want to put a thermal camera back on this, and we did all of that thermal camera stuff ages ago with the I2C interface to the thermal camera, pulling the array of temperature data out of it and then generating a ppm image of the board showing temperatures. And it has the same problem as trying to get a visible light camera to look at the device under test. There's just stuff in the way. So this is a problem that I'm kind of deferring because I don't have a way of dealing with it. Yeah, as Tinker says, so...
Tinker001 said, now
Yeah.
we're back to the problems with making a camera see through the pressure plate.
Yeah, exactly. And I don't have a solution to it. Taking good RGB photos, like visible light photos of the board in a light box is easy, relatively. But taking images of the board while it's loaded and under test, and when I say loaded, I mean like under load. So if, for example, you had a motor driver, perfect example, I don't have one in reach, but this is the test module for, in fact, no, not, I forgot those buttons aren't working. So this is the test module for a board with high current motor drivers on it. And on the back, those big white wire wound resistors are wired through test pins to the outputs of the motor drivers. So the point of this is that I want to be able to run the motor drivers into these dummy loads, essentially. So these dummy loads are going to get warm and measure the current. So I need to be able to see that the motor drivers are working. And I can characterize that by running the motor driver into the dummy load, and there are voltage sense points on both sides of the load. And there's also current sensing. So what I can do is make sure, yes, this motor driver really is getting up to voltage, it's outputting the correct polarity, the correct amount of current is being drawn, etc. I can measure all of that. And what I really want to be able to do, so this is the underside of the test module with the dummy loads, I want to be able to have a thermal image from the top so that I can see the temperature that the motor drivers are getting to. Because what I would probably want to do is load them up and run them loaded for some period of time. Like it might be 10 seconds, or it might have to be longer, I don't know. But long enough that they reach a steady state temperature, and then with the thermal camera be able to detect how hot they are. So doing that with the pressure plate in the way, which is going to be like this over the top, and then other parts of the structure as well. Oops, that goes like that. So we need to be able to see the board that is under the pressure plate and get thermal image. And also remember, clipped onto this magnetic latch in the middle is a big mechanism that is the pressure mechanism. So there's all of this mechanical structure in the way on top of the board that prevents you getting a clear view of the top of the board with either an RGB camera or with a thermal camera. So that is a problem that I do not have a solution to. Yeah, Tinker said, I think TTS will catch up with Tinker in just a second. Evil D says, when I was looking...
Oh, okay. 001 said, specific locations on a board would be most likely to show excessive heat first.
Yeah, that's right, absolutely. I agree. So putting a thermal camera in a location that just has a view of a small part of the board may be the solution. But I really would like to be able to get an overview of the board. But yeah. Oh, Wagonlow says your particle sensor should detect magic smoke. It should. Evil D says, when I was looking at fire detection for my lasers, I ruled out thermal and smoke for obvious reasons. If I recall correctly, I decided on IR, diff frequency to the laser. That was a few years ago and I still haven't built it. Okay.
At Tinker001 said, temp sensors instead of cameras.
Yeah. Yeah, and as this is going back in chat, I missed this a little bit. Tinker said, possibly put temp sensors in useful locations on the carrier PCB. That's a good idea. Yeah, they could push up against the bottom of the board. So the carrier PCB here could have a temperature sensor which pushes against the bottom of the PCB. And there could also be temperature sensors on, like, attached to the pressure plate that push down against motor drivers, for example, and get temperature readings off them. Now this is one area though where using a thermal camera just makes sense. So I want to be able to solve the whole problem of not having a clear field of view of the top of the PCB. I want to be able to point some kind of a sensor down at the board and get readings off it. Yeah. But I can't solve all the problems all at once. So, yeah. Oh, Michael says V3.0 of Testomatic now with added air quality sensor. Yeah. Yes. I know, detecting magic smoke, it seems like a fun thing to do. Like, hey, we could detect the smoke coming off the board and therefore we know it's failed. But the thing is that if a board fails so hard that it emits the magic smoke, it is also going to be showing failure in so many other areas that it's going to be super obvious. Yeah, the test system will know immediately. It'll have...
At Tinker001 said, multiple tiny robotic arms instead of the pressure plate.
Yeah, actually, Tinker. So one idea that, that my son Tom had was things like, imagine fingers that cam over and push down on the sides of the PCB. So let's see if we switch back to this view. When it's sitting in, imagine the PCB is sitting in here, coming up from the sides here, you could have curved fingers, and when you activate it, they rotate on a rod, like on a cam or something, and they go and just push down on the edge of the PCB. Do that from both sides and push down. Mechanically very complicated. That would be cool. It would leave the top of the PCB all exposed, and that would if you were very selective about where you put them, it could leave a clear view of the top of the PCB. The problem is that you actually need to spread pressure across the PCB, not just on the edges, because there is, if you look at this for example, the pins are distributed across the whole area of the PCB, and it takes significant force. You end up bending the PCB if you don't distribute the pressure. So with this, I've got 4 pressure points sort of towards the edges of the PCB. There is another pressure pin in the sort of center of the PCB, and then another 2 pressure pins that go on top of a connector. So there are a total of 7 pressure points onto the top of the PCB. This one is critical, because if I was just pushing from the edges of the PCB would bow up because of the pressure of the pins coming from underneath. What you need to do when designing the pressure plate is consider the location of all of the pins underneath so that you are counteracting the pressure and it is balanced. Tinker says, but the tiny robotic arms would be more fun. Yes, they would. And Wagonlay says, what about putting a thermistor on a power resistor to detect overload on the stepper motor? Yeah, so if you're talking about putting a thermistor on one of these external dummy loads, yes, potentially, but that is an indirect way of measuring power. A more direct way is that we already have current sensing on those power rails, so we can just measure that. We already have that pretty accurately with the INA 260s. So instead of turning on a motor driver and then some period of time later you detect that the temperature has gone up on the dummy load to a certain point, it would be better and safer to measure the current that is going into the motor driver, and if it is outside of the expected parameters, you just turn it off immediately. So you don't even give it time to overheat. You turn it on, you're monitoring the input current. If you get something out of spec, you kill the power. And that way you're less likely to do any permanent damage to the device. And it can immediately raise an alert and just say, you know, failure on motor driver 2 or whatever. And that could all happen within milliseconds rather than waiting for the physical mass of the resistor to heat up and then for your sensor to read that and then report it back. Yeah, must be undervolt, says Paul. What is, yeah, what is that a reference to? I know I've come across that somewhere before, but I can't remember where. 1201 program alarm. Yeah, there are going to be all of these pop culture references that I'm going to miss. Apollo 11. Ah, yes. Okay. That's what it is. Apollo 13. Yeah. Evil D says, Trinamic 2209 and greater stepper drivers have stall guard and will raise an interrupt if it detects excess current on the motor. Yep. Yes, if you are using a Trinamic, that is good. And you can do that. But in this particular case, it's not. It's yeah, the motor drivers on the target board are not Trinamic motor drivers. They are 40 amp half H bridges. So yeah, not quite the same. Which is why instead of doing that, we use INA 260s as the current sensors. Okay. What? I don't know. You know, my goal today was to hook this up and actually do something with it. But I've ended up blathering on for so long that I'm not going to do anything useful. So, just talking as usual. But one thing that has come out of all of this is that I have made a decision. And this decision is likely to make Austin happy. This decision is that I'm going to put, where is it? It must be further along here.
More squirrels.
Yeah, I'm going to put quick connectors on all of my test pin carrier boards, just by default from now on. Because what I realized is that external sensors, things that I might want to attach to the pressure plate, for example, or other devices, will probably need to plug into the test module. So what I'm going to end up with is I better grab the right one, this one, the test module. Hang on, back to this view. So I'm going to end up with the test module, which plugs into the chassis. It's got I2C brought up here. to be passed through to a connector on the back. So there'll be the quick connector on the back, and it may not be used, but it may be used in future. So if, for example, I wanted to do, not that pressure plate, this pressure plate. Say I wanted to do a pressure plate that goes onto it that has a color sensor or an IR camera or whatever, it doesn't really matter. I2C is there, and then this can be plugged in, and I'll have the module with the pressure plate tethered by the I2C cable, and that electrically is a single unit, even though it consists of two parts. It's mechanically got the test module and the pressure plate, but they can still all be connected through the same edge connector to the test-o-matic chassis. So I'm regretting that I didn't put them on earlier. I know Austin for ages has been saying, yeah, put quick connectors on, they're great. And I've been ignoring him. I should not ignore the wisdom of Austin.
At Tinker001 said, always better to have the cheap option built in than to discover the need later.
Yeah, that's right. So from now on, I'm going to include those on the test pin carrier boards. And for this, I'm going to retro bodge patch fit one onto this board without revising the PCB. So I actually have revised this PCB. In fact, this is the GYM version 1.1 test module. This is the version 1.2. And the difference is it includes the quick connectors on it. This one that I have in my hand doesn't. So I could send this PCB off for fabrication, and I might, but in the meantime, I'm just going to patch one onto this existing PCB, which will allow me to test the idea before incurring more expense. Yeah, so I am, Wagonline says, can you or will you need pogo pads for I2C for Easy Connect? Ah, that's an interesting idea. It could be made so that when the pressure plate descends, yeah, I see where you're going with that. I think it would add potential failure points and more complication. It's an interesting idea though.
WIIC breakout board on there.
Hot glue a quick breakout. Yeah, that is almost what I'm going to do, except that I'm going to get an actual connector. So what I'm going to do is I'm going to scrape back the silk screen, solder mask, sorry. I'm going to scrape back the solder mask to the ground plane and solder the mechanical mounting pads of a JST 1mm connector on there, and then patch wires onto the pins of the connector. So it should end up being a fairly neat sort of job. John said, can I ask, will there be a barbecue in January, as I'm planning a holiday in Melbourne and would love to meet everyone? That would be so cool. Hang on, yes there is the short answer. I am just going to bring it up now. I need to update this page because the date has not been updated. So the next one is Sunday, January the 11th. And details are there. So John, go and check out superhouse.tv/barbecue. In fact, what I should do is edit page. I'll see if this will let me. Word fence installation is incomplete. Yeah, go away. Oh, not in 12 hours. There's this plugin in WordPress which needs an API key or something set up, and it comes up with this big warning banner when you log in, and then you can click the go away, don't remind me thing, and when you do that it says, okay, I won't remind you for 12 hours. Great, thanks. A whole 12 hours. So what I want to do is go something like that and make that non-bold, make all of that bold. And so Sunday, January the 11th, 2026 is the next one coming up. And then what is after that one? It'll be March. So yeah, it'll be February, March. Second Sunday is the 8th of March. So Sunday, March 8th, 2026. I'll just put that one in so that the next one coming up is not the last ever date. Save. Oh no, John, don't get there until the 21st. Oh, that is really unfortunate because I'm going to be going to Canberra for Everything Open, which starts on the 21st. So, John, if you do happen to be in Melbourne, oh, how long are you staying? If you, you'd need to be here for more than a week because I'm going to be gone in Canberra for Everything Open 3 weeks. Oh, okay, so you will still be here. Well, maybe you should come and visit anyway, even though there won't be a barbecue at the appropriate time. Yeah, come and check out the lab. So, yeah, you should do that. And for everybody else, January the 11th is the next barbecue. I am going to go because I am definitely feeling quite crook today. Struggling. My head is not good. My lungs are not good. So I've got that cough that has recurred. John and John Private Barbecue. Yeah, we can do that. And I'm just feeling queasy in general. So I'm really not going to push on today. Yeah, which means I've got to figure out how do I end this. Normally I click that button there, but that's not going to do anything useful. Okay, I've got to do this in OBS manually, which means switching to that scene. Okay, I think I've got it figured out. So, thank you for coming along. I apologize for the state of this stream. I was not on top of things today. I started off not in control of the situation, and it just went downhill from there. And I didn't do any of the things that I was expecting to do today. But oh well. Oh, I just need to go and lie down on a couch or something now. I'm wiped out. My energy really is depleted at the moment. So thanks for coming along, and yeah, and suddenly halfway through a sen. Yeah, like I heard once, that's the trick. If you're on a phone call with someone and you don't want it to continue and you don't want it to seem rude, you just want to hang up on it, don't hang up on the other person while they're talking, hang up on yourself. So you can be just talking, and then as you're talking,